Welcome to bite-sized tutorials where we break down complex topics into quick, easy to digest lessons. Let's talk about Kubernetes architecture. To work with Kubernetes, you don't need to understand every detail of its architecture, but having a basic understanding can help you troubleshoot and optimize your cluster more effectively. Tools like kubeadmin for on-premise setup, as well as managed services like GKE, EKS, and AKS provide most of the architecture out of the box. However, understanding the components can still be valuable for making informed decisions. Kubernetes architecture consists of several components that work together to manage containerized applications. Let's start with the nodes, which are the machines, either virtual or physical, where your containers actually run. Each node contains a kubelet, an agent that communicates with the control plane, ensuring that containers are running as expected on the node. Proxy. This component manages networking rules and allows for communication between different services within the cluster. Container runtime. This could be Docker or another container runtime, and it's responsible for running the actual containers. Above the nodes is the control plane, which acts as the brain of the Kubernetes cluster. It manages the scheduling, scaling, and the overall state of the cluster. The main components of the control plane include API server, the front end for the cluster where all administrative tasks are handled. It serves as a central communication point for the cluster components. etcd, a distributed key value store that holds all the cluster's configuration data, ensuring consistency across the cluster. Scheduler. This component decides which nodes will run the newly created containers based on resource availability. Controller Manager. It continuously monitors the state of the cluster, ensuring that the desired state is maintained. For instance, if a container fails, the controller manager will automatically restart it. Together, the control plane and nodes create a robust system that automates the deployment, scaling, and management of containerized applications. This architecture allows Kubernetes to self heal by restarting failed containers, scaling based on traffic, and rolling out updates seamlessly. That's it about Kubernetes architecture. Stay tuned for the next topic where we will dive into how to deploy your first pod and get started with Kubernetes hands on.